Okay, good afternoon, ladies and gentlemen. So our objective for today is that students will be able to apply the rules of exponents to simplify expressions. So what we're going to be learning over the next couple of days is something that we refer to in math as the rules of exponents. They're just a set of rules that you use when working with terms that involve exponents, right? I'm going to try to, instead of just giving you the rules and practicing it, have you understand the actual rules and why they are the rules by kind of playing around with the math yourselves, right? And kind of discovering them naturally. So first rule that we're going to look at is something called the product rule. And don't worry about what this is over here, but that's what the product rule looks like, right? The way that we're going to explore this is by looking at a couple of examples, and we're going to first write them in expanded form and then rewrite the expressions in exponential form. I'm going to explain what that means for some examples, then you're going to practice it yourself. So looking at this example over here, it says 2 to the third power multiplied by 2 to the second power. So the goal is to take this multiplication sentence, because again, remember, right? The product is multiplication. Try to take the sentence and write it with a single base and a single power, or exponent. So in this case, my base is 2, the exponent is 3, multiplied by 2 to the second power. So my end goal is to write 2 raised to some power. So when I say expanded form, think about what this means, right? 2 to the third power really just means 2 times 2 times 2, right? That's 2 to the third power. So now it says, let's just put that in parentheses to make it a little bit easier, right? That's 2 to the third power. I'm going to take all of that and multiply it, right? Multiplied by 2 to the second power. So let's put another set of parentheses. So 2 times 2. So left-hand side here, 2 times 2 times 2, that's 2 to the third power. Multiplied by 2 to the second power, that's this right here, right? Now, everything here is multiplication, so I actually don't need these parentheses. Let's get rid of those. And what you're gonna see is this actually, once I get rid of all those parentheses, looks like 2 times 2 times 2 times 2 times 2, right? So I can now simplify that, and instead of writing 2 to the third times 2 to the second power, I can write, and I'm gonna show you guys how to do this. Go to Insert, Equation. You're gonna hit equation, that gives you this little blue box over here. 2, shift 6 gets me upwards to that exponent, or a second way that you can do that is go over here to this equation editor, hit math operations, this one right here, x to the b, that's gonna be your exponent. So tap that. So 2, and my exponent's up top there, right? Actually, I hit this first. 2, right key, to the 5th power, because I have 1, 2, 3, 4, 5 2s. I'll do the next one with you as well. 3 to the 4th times 3 to the 3rd power. So that's 3 multiplied 4 times 3. 3 times 3 times 3 times 3, so that's 3 to the 4th power, and now I need to do multiplied by 3 to the 3rd power. So that's just going to be times 3 more 3s. So times 1 3, 2 3s, 3 3s, right? So 3 to the 4th power times 3 to the 3rd power is equal to, again, go to Insert, Equation, that's, now I'm going to hit here, exponent, 3, right arrow key, raised to the 1, 2, 3, 4, 5, 6, 7th power. All right? So you're going to do the same exact thing for this example, this example, this example. Write out the expanded form. I want to see you writing out how many times you have to multiply it, and then your end result with 1 base and 1 exponent. All right? After that, what I want you to do is try to write out in words. It says, what do you notice happens when you multiply 2 powers with the same base? So how are we getting from here to here, right? Think about what's happening with the exponents. What's the relationship between the exponents 4 and 3 and the exponent 7 in the end. Same thing, what's the relationship between the exponents over here, 3 and 2, and the exponent 5 in the end? Try to write that out in the sentence. And then the last thing just says to finish the following equation to express what you noticed above, right? This part here, I'm gonna go over during the live session, so you're gonna have to come to see me go over this section, okay? Now, next part, it says use what you learned on the previous page to write each of the following expressions with only one base and power. So the idea for this one here is to go straight from this form using what you learned to go to the exponential form, right? Skipping this middle step here, expanding it all out, using what you learned to write each of these out here, right? Once you're done with that, we're heading into the quotient rule. So you can pause the video if you're not done yet, unpause it when you're ready to go. So quotient in math means division. So what we're working with this part here is dividing instead of multiplying. So same idea. I'm gonna start with what I have here and write it in its expanded form first. So this here, use it as a fraction. So on the top, 3 to the 5th power, that's just, 3 multiplied 5 times. So 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, double count to make sure you got it right. The denominator is 3 times 3 twice. Now, I need to figure out how to write this in exponential form, but right now that doesn't look that simple to me, right? But what you have to remember is that when you're working with fractions, if you have the same number on the numerator and the denominator, you can actually cross those out, all right? So basically the 3 that I have on the top and a 3 on the bottom, that's gonna divide to 1 because 3 divided by 3 is 1. So I can kind of get rid of a 3 from the top, 3 from the bottom. It's like a scale. Same thing, I can get rid of a 3 from here and a 3 from here. So I got rid of 2 3s from the top, 2 3s from the bottom. All that I'm left over with is this right here. So in essence, this here is actually just equal to 3 raised to the 3rd power, because they have 3 times 3 times 3, all right? I'll do one more example for you, and then you do the rest yourself, all right? So 4 to the 7th power, I have 4 7 times. 2 4s, 3 4s, 4, 5, 6, hopefully this is big enough, 7. All right, down the bottom, 4 to the 5th power, so 4 5 times. 1 2 3 4 5. So on the top, 1 2 3 4 5 6 7 4s, 1 2 3 4 5 4s. All right, so same idea as before. I'm gonna cross out 4s that I have on the top and the bottom because they divide to 1. So 4 divided by 4 here is 1. 4 divided by 4 here is 1. Same thing. This one with this one, this one with this one, this one with that one. So I cross out 1 2 3 4 5 from the top, 1 2 3 4 5 from the bottom. I'm left now with only 2 4s. So what I can say now is this here is actually just equal to 4 raised to the 2nd power, right? So all this here simplified just down to this. Now, you're gonna do the same exact thing that we just did here, and you're basically gonna replicate what we did with that previous page, all right? So after you're done with that section, you're gonna, again, write down what you noticed. So what relationship do you notice between the exponents that you started with and your ending exponent, right? Then again, I'm gonna go over this rule in class, but what you can also do is work on this section here where you're doing the same thing. Again, you're trying now to go directly from this step to this step, skipping the expanded form in the middle once you understand what's going on there, right? This is some stuff that we really have to understand before we go into algebra next year. So make sure you try it. If you finish early, the push yourself section is going to kind of combine the two rules together and also throw some variables in there at you, all right? So good luck. If you have any questions, please come to the session and we will go over this stuff later.